Last night, Martin Chilcott of 2 Degrees Network, a business-to-business platform, which I rate very highly, was talking very excitedly about a new tool that they've developed. Well, Martin, we've got a new tool as well, and Ben Dixon, I hope, will talk a little bit about that one, and it is addressing carbon productivity.
Sure. In fact, I've forgotten my very important prop, which I'll just get before I start.
Looks like a hospital sample.
Well, I'll explain. Do I have slides on here? So Systemic is part of the Carbon Productivity Consortium, which John has introduced this morning. And our job, and the reason that I carry around a bottle of oil with me today, is to bring us down to earth. So it's our version of drawdown, Paul. So we've talked a lot at a conceptual level, and a really compelling vision around carbon productivity and how we generate more value from less fossil fuel carbon. But the tasks that we were given by John as part of the consortium was to define a practical tool that can measure and improve carbon productivity and can be applied by a company or a group of companies working together. And the purpose for this session in the next 15 minutes is just to share with you what we're calling a beta version of this tool. And I really like to stress the fact that this is a beta version. And I'm guided, one of our other partners at Systemic was on the founding team at Skype, and he introduced us to the idea of ready, fire, aim. And this was the concept that really built Skype. And he said that they would never have succeeded with that huge breakthrough company, which you could argue is a breakthrough carbon productivity invention as well, if they hadn't have adopted this concept of ready, fire, aim. So today is the fire of the beta tool. And the invitation to everybody here, but also to other people that you think would be interested, is to join us and work with us on the aim of this. So we'd really like to, basically my goal for this session is that enough of you are intrigued and interested in what we're doing to send me an email afterwards or to talk to John and see how we can work with you to refine, to develop and to apply the work that we're doing. First of all, we don't have a universal answer to this, and we've deliberately tried to focus, because as we're trying to draw down from what is a very broad concept, we've tried to focus on something that is applicable to our industrial value chain, and Martin started to introduce this earlier. And so it's something that we think at this stage is applicable to industrial companies that are making things. So we're really thinking about product value chains. There's a much wider story of carbon productivity, and we recognize that we don't have a universal answer to address the full scope of what we're talking about. But I guess over time we'd love to expand. And so if we think about industrial systems and carbon productivity, and going back to Paul, and we've certainly been guided by Paul's work in thinking this through, a simple definition of resource productivity would be the value created or the value derived per unit of input. And that gives us 3 questions. Firstly, how do we define value? Which is a very long answer, to be honest, especially when Martin, who's been leading this project, is an economist. But I'll give you the short answer, which is to say at the moment we're defining value in 2 ways. Firstly, in terms of the financial value we can derive from carbon, and secondly, in terms of what we call environmental value, which is the positive impact of products during their life cycle. So as Richard has already talked about, some products that we can produce will have a net benefit on fossil fuel consumption during their life because they contribute to energy efficiency or renewable energy, or efficient transportation. And so we think about financial return and we think about environmental return. The second question is, what do we mean by carbon? And I think, again, going back to Paul's introduction, the way we think about carbon is we're thinking about carbon as an input to our industrial systems. And this is a mind shift, and it's a really deliberate flip and a deliberate switch that we think is helping us to think about a different mindset around carbon. So we're no longer thinking about carbon as a toxic waste product. And again, it comes back to Erin's points earlier. I feel there's a lot of alignment in what you've heard this morning. It's no longer thinking about it as a toxic waste product, but we're thinking about it as a value-generating industrial input. And in particular, we're thinking about how do we generate more value from less non-renewable carbon. And when I talk about non-renewable carbon, I mean this stuff, coal, oil, and gas. The third question was, what do we mean by an improvement tool? And our goal with an improvement tool is a tool that can help companies to navigate this difficult jigsaw So we know there are many different levers you can pull as a company to improve your carbon productivity. And what we'd like to do is to help companies prioritize, assess, and think about that landscape and how they navigate that landscape. So for some companies and some products, the best thing you could do might be to switch from fossil fuel carbon to bio-based carbon that comes from plants. But for other companies and products, that might not be the most important lever to pull. So we'd like to produce a tool that can help people to navigate this landscape. The reason we are concerned about increasing carbon productivity can be summarized by 3 lines on a chart. And these 3 lines are credited back to McKinsey and to Jeremy Oppenheim from the study they did in 2008. But the 3 lines tell us that if we want to maintain our climate within 2 degrees of today's global temperature, we need to reduce our fossil carbon consumption around 2% per year. If we want to continue to have healthy and productive economic growth that will bring people out of poverty and achieve the SDGs, let's say we continue with today's rate of global economic growth, we need to grow at 3.5%. And if we put these 2 together, carbon productivity requirements, i.e. value per unit of carbon, would need to go up by around 6% per year. And if we think about 2050, that means between 2010 and 2050, we need a 10 times improvement in carbon productivity. So we're coming back to the 10x. I promise I didn't cook the numbers, but we're getting a lot of consistency around the message here. This is something that is a huge and radical shift for our economy. It has been done once before. So the labour productivity example during the Industrial Revolution achieved a 10x growth in labour productivity. That's the good news. This is not the first time that society has had such a radical shift. The more challenging news is that during the Industrial Revolution, that took 125 years, and this chart requires us to do it in 40 years. So in designing the tool, the question we asked ourselves was, what do companies need to improve and to really think and drive breakthroughs? The first thing is measurement. So we think they need a stopwatch or they need metrics. The second thing is an improvement framework, as I've described. And the third thing is a collaborative methodology that will help companies to work together on these solutions. I'll start with the metrics. We've developed a number of different metric options, and we're calling this like a suite of metrics because different applications will require different measurement tools. And also we want to make sure that there's scope here for people to become involved and to help us to develop this. So at the moment we have quite a large suite of metrics. I'm putting 2 on the slide to give you a sense of what the metrics can tell us. The first one, very simply, is a financial return on carbon employed. And the question is, how much revenue are we generating per unit of non-renewable carbon or per unit of fossil carbon? And we think this can be a very powerful tool to allow companies to track their performance, to set targets, and to measure, over the course of a year or 10 years, how much more revenue can we generate for every barrel of oil that we're using as a company. And the second one comes back to this concept of environmental value. And for products that have a positive impact during their life cycle on carbon consumption, we think it could be quite powerful to really measure the ratio between the carbon avoided during their life and the carbon required to produce them. And the reason I put the solar impulse plane here is that this is a great example of a product that during its life cycle would repay vastly more carbon than it takes to actually create that product in the first place. Second thing on our chart was the improvement framework. And as Martin had alluded to, we went back to the natural carbon cycle, and similar to Paul, felt that we needed to really ground our thinking in natural carbon flows and the way that carbon moved in nature before the humans were around, which is like this, in the simplest possible way, a balance of carbon flows and stocks between geological sinks, biological cycles, and the atmosphere and oceans. Secondly, an understanding of what did humans do to this carbon cycle, which is to drastically increase the flow of carbon into the atmosphere and the oceans, and to introduce the idea of technological sinks and cycles, which is carbon captured into industrial systems and into materials. And that allowed us then to really deep dive on the grey box, which is carbon in technological cycles and sinks. And this is the diagram that Martin showed you, where we mapped a simple industrial value chain and really thought very hard about what are the levers that companies can pull across this value chain to increase their carbon productivity, and came up with the acronym of RIPPLE. and we would welcome feedback on the acronym or ideas. And RIPPLE stands for recouple, i.e. switching our feedstock to non-fossil fuel-based carbon, improving through efficiency or switching to renewable energy, product and business model design, so this idea of carbon-positive products, but also products that may be more suitable for the circular economy, and finally looping materials and products through reuse and recovery at the end. So we think this very simple map can help us to navigate these options and these potential solutions for carbon productivity. And last of all, I won't go into detail on the collaborative methodology, but our realization, as we talk to people about this project, is that carbon productivity breakthroughs are very likely to be team sports. And certainly I think Richard's reflections on how the breakthrough they had around CO2 capture and how that's being commercialized and brought to market is not a Covestro only initiative, that's a team sport, and it involves multiple companies working together. So we'd like to produce a tool, and we've developed a prototype for how companies can use this framework to have a quantitative conversation about carbon and to really decide where are the biggest things we can do as a value chain and how do we fairly distribute the effort across these companies. And the final caveat before I talk about my bottle, which is that I don't want anybody to leave the room thinking that we have come up with a silver bullet here or anything that replaces the existing and well-used, well-adopted and hugely important carbon metrics that already exist. So we think that what we're doing is complementary and additive to things like the Greenhouse Gas Protocol and to the initiatives like the Carbon Disclosure Project and Science-Based Targets. I could list many others on here. We're not trying to replace anything. And it's also grounded, and the foundation of the work is on life cycle assessment. I will finally talk about my bottle. And our fun fact for the day is that a 1 litre plastic bottle requires approximately 100 millilitres of crude oil to produce. Does anybody know that before? Okay, good. Well, we've learned something today, that's good. And about 40% of that is feedstock, so that's the carbon that then goes into the polymer that makes the plastic bottle, and about 60% is the energy requirements to make the plastic and then form the bottle. This will make you think differently about ordering bottled water, maybe. If you add in the oil required to make the energy required to make the water and transport it around, it's another 100 mils. So you can think about every bottle of water that you buy is actually 200 millilitres of oil inside it. The reason I'm telling you this is because a very humble product like this can actually help us explain why this RIPPLE framework can be powerful. So if we take 100 PET bottles like this, that's 10 litres of crude oil. If we recouple the plastic away from fossil fuel feedstocks and towards bio-based plastic or CO2 capture, which is possible now, or to recycled inputs, we can knock 3.5 litres off that total. This is all preliminary illustrative analysis, so don't quote me, but I'm confident that this is about real numbers that we could do today with known technologies. If we improve through our production processes and efficiencies, we can knock almost another litre off. If we design the product differently, particularly if we reduce the amount of plastic we need in each bottle, we knock off another 2 litres. And if we then recycle this plastic at the end of use, we can knock another 2, or we can credit another 2, because that knocks oil consumption off the next system. So overall, we can go from 10 litres to 2 litres using known technologies. If the revenue stays the same, and I would argue you might even get more money for this because of the fantastic consumer appeal of a bottle like that, even if it doesn't increase, you'd get a 5x carbon productivity improvement just from using the known tools and levers that we have. And I will conclude. Thank you for listening. Just encourage everybody to think about it, and if you are at all interested, please get in touch, and we'd really like to hear from you and work with you to test and apply this tool. And this is what we're trying to do. We're trying to provide a practical tool, but also a tool that can change our mindset. Thanks a lot.